Okay, guys, probably one of the less exciting of the material areas, polymers or plastics. Right, so the main families of polymers are you get thermoforming, you get thermosetting, and that's it. So, yeah, fairly easy. Thermoforming, there's a lot more of them than there are thermosetting. The main difference between the two thermoforming, thermo means heat. Thermoforming plastics can be remelted. I mean, that's basically it. These ones can be recycled because they can be remelted. Thermosetting plastics mean they set with temperature permanently. So once they're set, they can't be remelted. So these ones are non-recyclable, but they have other benefits that thermoplastics or thermoforming plastics don't have. All right, so these are the most common ones that are used, and these are ones that you will use in school. We don't really use thermosets in school because they're much harder to work with. Okay, so let's just go through some basics, and you've got some examples just to remember for each one. Right, acrylic is one that we've used loads. You guys definitely have used acrylic at some point, probably for the laser cutter. Acrylic's great because it's got a relatively low melting point. It comes in a range of colors, and also even if it comes clear, it's got really, really good optical properties. So it's very, very clear, which is excellent. So you can use that for, yeah, I mean, even car headlights casings are really well. Acrylic's a good choice for them because it's optically clear, and acrylic's fairly tough and it's quite hard as well. The only downside is it is a bit brittle. High impact polystyrene, or HIPS for short. Just think of HIPS. This is the one that you'd use on something like the vacuum former. If you've ever used the vacuum former, you'd use HIPS on that because, again, it's got a very low melting point and it can be formed very easily around forming shapes like MDF molds or whatever. It's called high impact polystyrene because it's pretty hard and it's pretty tough when it's not soft, when it's not being heated. So yeah, it adds a good layer of protection to whatever it's containing. HDPE is a really good sort of all-rounder plastic. It's strong, tough, it's durable. It's got really good chemical resistance, and it's used for loads of injection molded products. So things like buckets or casings for things are the chance, or big boxes, storage boxes or something. They're probably HDPE because it's so durable. The next one's polypropylene. So this one's a little bit softer. It's still quite tough and it's still got good heat and chemical resistance. And this is typically used for drinks bottle caps. PVC, or polyvinyl chloride. You might have heard of that in terms of it. PVC is sometimes used for like other things, like you can get sort of faux leather clothing or shoes or something that are made from PVC. But in this instance, PVC, a common application is for just like pipes that are used for plumbing or water or something like that. Because again, low melting point, very, very easy to cut into lengths, and yeah, it's just very easy to work with. Then the last one is PET, which stands for polyethylene terephthalate. I wouldn't bother remembering that, just remember PET. When you hear PET, just think plastic drinks bottle. PET, it's very lightweight, it's tough, it's impermeable to water, and it's very cheap. And also it's food safe. Not all polymers are food safe, so apparently PET is food safe. So that's why it's used for things like food packaging and water or drinks bottles and things like that. Let's go on to thermosets. Thermosets are so called because they are non-reactive to heat. Once they've been formed, they actually undergo a chemical change where the molecules in the polymer actually change their links, and to the point to then be in a position where the polymer chains cannot loosen even with the application of heat. So they stay bonded tight even when it's really hot, so they don't soften. This is great for high temperature applications. So things, well, urea formaldehyde, UF, is a very commonly used thermosetting plastic. And the example I always give is plug sockets. The reason being is plug sockets, in case there's an electrical surge, if there's an electrical surge like in a thunderstorm, there can be a huge amount of heat that will go through the wires. If you have a thermoplastic, it would probably melt the plug socket face. Then that's dangerous because you'd have exposed wires and stuff. So having a thermoset as the facade is much safer. Melamine formaldehyde, or MF, is commonly used for, yeah, like flooring, like the flooring in the DT workshops is MF because it's really durable and it will last a long time. It can withstand knocks and scratches and heavy like items being placed on it, like workbenches, or if you drop something really heavy like a vise, it won't dent. If you drop something really sharp on it, it won't really cut either. Yeah, it's a very, very durable material. And you actually get some, like, there used to be some sort of like crockery, like plates and bowls made from MF a while ago now. They don't so much now, but okay. Then epoxy resin is a great material because it's actually starts as in liquid, is a liquid form, so it has a resin and a hardener, and you can mix it up and then put some dye in it, and then yeah, you can pour it. You can pour it into a mold, or you can make stuff yourself out of it. So this can be used as a glue. So there's a glue called araldite, which is actually an epoxy resin, but it's also used for making things waterproof. So things like boats, wooden hulled boats would be coated in epoxy resin after they've been made because it makes them completely waterproof. Wooden surfboards are coated in a very thick layer of epoxy resin after they've been made because then it adds a totally waterproof seal, and it's really tough and durable. And also it's got great optical properties. It can be totally transparent. I mean, this had some dye added to it, but it's very, very, very good for optical properties.